Here's how we delete a node in a doubly linked list. It's very similar to the linked list operations. Suppose this is the doomed node that has to be removed. We'll follow the same process before. We will disconnect it from the list and then delete the memory allocation. So to disconnect it from the list, we've got a couple of problem pointers that will need to be rewired. The first one is this one right here. The second one is this one right here. The previous node's next pointer is going to have to get shifted over to here. And then the next node over here, that previous pointer needs to be redirected then over here. So here's how the new configuration would look. And now that those pointers have been redirected, then this memory cell is completely disconnected and can simply be deleted, and we are good. So let's take a look next at the code that does all of this. Here's the first case. If the linked list happens to be empty, we just have to catch that and handle it. So that's what this line does right here. It just checks, and if there is no head, then that means the list is empty. We've got this situation over here. And in that case, we just back on out of there, get out of there, and we don't need to do anything. So let's take a look at the next case. Now, next in our delete node code, we create the pointer, and this is just a pointer called temp. And we will have it point to head, wherever head is over here. We're just going to point to it. And then this code block is going to advance that temp pointer, and it's going to go and search for the search term. This particular delete node method is going to delete by term rather than delete by position. And one of your homework exercises is to come up with the code to delete by position. But here it's going to delete by term. We are searching for this search term, and it's going to then just step through the entire list. And when it finds that term, it stops. And we will result in the temp pointer pointing right at that term that's going to be deleted. And so schematically, it'll look like this. So we can see here, as we just traverse through the lists, we are going to increment the temp pointer each time going through, and we end up with temp pointing right at the element right here when it is found. Now, the next line of our code here is just another check. It's this one to make sure that we haven't stepped all the way past the end of the doubly linked list. And this could happen if the search term's not found. So this particular statement is just the guard for that. In case the search term is not found, then temp is going to go all the way to the end, past the end of the doubly linked list. Now, if we get then to this part in the code right here, that means that we have successfully found the search term, and now we just have to do the rewiring operations. Now, this first code block in our code is going to go and find the element. We've already found it. Temp is pointing right at it. And it is going to first check and make sure that this node to be deleted is not the head. Because if it is the head, we have a special situation. We just need to pipe reroute one pointer. So if it's not the head, and the way that we tell that is, if temp currently is pointing to the head here, it'll mean that temp prev is invalid. In other words, temp prev is pointing to the null pointer. And that's what this is right here, temp prev, and that's pointing to the null pointer. So this is saying that if it is not, or if it's valid, well, then let's just plumb these, rewire and replumb these pointers. So the first thing we do is this one right here. We're going to say temp previous next. So Right here, temp is currently right here at this one. That makes this node temp prev, and then that makes this pointer right here temp prev next. And what we're going to do is set that to temp next. Temp next is this one right here. And we're just going to then take this pointer right here and rewire it over to here. And that then gets rid of these right here. Now then the next code block here is going to do the same thing, but we're going to check and make sure that the node being deleted is not the tail. And how does it detect that? Well, it checks to see if temp next is valid. If it is the tail, if temp is the tail, well then this is the temp next pointer right here where that little arrow is, and that points to the null pointer, which is invalid. So it just covers that case. Otherwise, it is going to do the exact same code, but just flip the parity. It's going to change this and this and this and this, and just flip the parity on all of those. The prevs become next, the next becomes prevs, and that just deals with then the case at the tail. So this is the code walk through deleting a node, and I hope this helps. Also check the page in Blackboard for how to go about deleting an entire list. Pretty self-explanatory. Okay,